Hello and welcome to today's webinar. Today our topic is Beyond Hadoop, how to supercharge your analytics with Dremio and MinIO. Next slide please, Ravi. So today we have a joint presentation between MinIO and Dremio. So joining me today is Ahmed Musa, he is the field CTO for the Meta region at MinIO. And from Dremio is Ravi Gupta, the principal pre-sales solutions architect. And myself, I'm the evangelist for EMEA here at Dremio, and I'll also be taking part in today's discussion. Next slide. So today's agenda, we're going to start off talking about Hadoop, talk about where it is and some of the limitations in it. And then we're going to go on and discuss how to accelerate BI use cases and pipelines on Dremio. Then MinIO will talk about the high-performance AI data store that they offer and how this can contribute to a modern data lakehouse. And then we're going to collaborate and discuss about how easy it is to migrate from Hadoop. So we're going to talk about the ways you can transition from a Hadoop architecture to a modern data lakehouse. And then I'll close out the session and talk about open architectures and the power of vendor independence. If you have any questions throughout the session, there is a question box on the side in the chat. Please feel free to put your questions there and we'll close out the session and answer those questions for you. Okay, let's get started. This is me, and I'm going to talk about the current state of Hadoop. Next slide, please. So, Apache Hadoop. It's belonging to the Apache Software Foundation. It's an open source software platform, and it's Java-based. Its main application, its main use, is for handling big data. So to deal with this, it has two major functions, one around storage, one around processing. So first up, HDFS, the Hadoop Distributed File Store. This divides and stores large files across many machines. And then for processing, their main innovation was MapReduce. So this processes large files by splitting them into smaller chunks that can be processed in parallel. And this was a great technology. It has lots of key benefits. The three main ones here I'm going to talk about are firstly scalability. So you could parallel process and horizontally scale your architecture. So if you had large amounts of data and it fluctuated and got bigger, you could scale your deployment and your processing very easily. It was also very resilient. So you could replicate any node within your cluster to other nodes. And this helped deal with failures, whether they're hardware or software failures. And finally, you had flexibility. So coming from older database or data warehouse systems, you also had the ability to store unstructured data, which was of great benefit. However, time moves on, and so does technology, and Hadoop architectures present a few challenges, and I'll discuss some of them on the next slide. So there are some risks and limitations with Hadoop. First of all, you've got management complexity. So it's a great stack, but it is quite technical. You need deep expertise in the Hadoop ecosystem to manage and maintain your system. So things such as HDFS and MapReduce, but also Yarn. There's also growing costs because your storage and compute are coupled. So if your data goes up, you have to pay for more storage, but you also end up paying for more processing, even if you want it or not. This is really kind of caused by Hadoop being designed around on-prem architectures. And cloud architectures have come in and they are more cost performant. And in that kind of environment, Hadoop's cost effectiveness trails off a little bit. There's also poor performance for certain things. If you're doing SQL-based analytical workloads, your query performance and lack of concurrency is an issue. And quite important for a lot of analytical use cases is you don't have guaranteed ACID compliance, which is a headache. And then finally, lack of self-service. So this kind of ties into the technical complexity for the management, but the systems you're using, it's Java-based, you're using MapReduce. These are quite high technical barriers for entry. So if you're trying to deliver self-service analytics, the idea of opening your analytics up to non-technical users, it can be a little trickier with Hadoop. And on the right, we have a quote from one of our Dremio customers, NetApp, who we helped migrate and move away from Hadoop to a modern data lakehouse. And they saw some of these pains themselves. So one challenge they've mentioned here is that the compute and storage, the costs go up. But they aren't our only customer who we've helped to move away from Hadoop. Next slide, please. So we've also helped TransUnion and NCR. So TransUnion saw a 10x performance gain improvement immediately from switching to a data lakehouse. NetApp, they had their cost issues, but they saw 7x performance improvement. And finally, NCR had a 30 times improvement on the speed of their dashboards. So their BI got a lot quicker. So on the topic of BI, I'm going to hand over to Ravi, who's going to talk a little about how you do that on. Hi, sorry, apologies there. Ravi, you're muted.
Oh, I'm sorry. I thought. Sorry. So uh, I was saying that the whole journey of the data set, what we have seen from the real time customer is that even if they have a big data lake setup in place, if the business requires some analysis to be done, uh, that requests come to the data engineering team, and the data engineers understand those requests and then try to find out what are the sources available. And if the sources are not available, they will start creating either sources or go into the backend systems that where is this data available. What we have seen that the business requirement and the business idea which wants immediate action, uh, a lot of time is spent on the data engineering side and analysis side, that how data will be available for business to utilize it. And it may take from weeks to months sometime, and businesses struggle even if they have a big data system in place. So what Dremio is doing is Dremio is making the overall life easy for the business users. Um, as I said, in the left-hand screen, you see we have a lot of source systems, and what data systems have been doing is this: they are transforming data into a data warehouse, and maybe if this is not performing well, they bring it to cubes, and then it is being consumed by the business users or the BI teams. And they have been struggling into this whole transformation of data and creating multiple copies of data. So Dremio simplifies the whole task, and it brings all the data sets available into different sources, and it presents everything into one layer. And then in that layer, users can see all the available data set. They can even play with the data set, and they can make their own data products and data sets and make them visible to the BI teams or the business users. So Dremio architecture is overall simplifying the whole process, and it reduces the complexity of bringing data from different systems and transforming them, and making the overall journey of the data from the business user side. They will immediately able to play with the data or analyze data or get more value out of the data. If you go a little bit inside the Dremio architecture as a lakehouse platform, We have a native SQL engine inbuilt, and that engine has a capability to read open file formats like Parquet or CJS and CSV, etc. But at the same time, it can also connect to any of the popular data lakes, data sources, and then bring all the data sets available to a single pane of glass, and then users can play with the data. At the same time, we have also a catalog available in Dremio, and that catalog makes uh, more easy in terms of the governance of the data set and which data sets will be visible for the business users, which data sets will be visible for the uh, AI and ML users, and which data sets will be visible to the data engineers. We can fully control that. And this catalog is also making other engines to consume the data set through Dremio. So one place where people can develop data products, data sets, discover the data, govern the data, do the observability of the data, and they can deploy in the choice of their platform or the infrastructure. Um, Along with this architecture, there are a lot of native features inbuilt into the platform. And as I said, people are getting good performance through Dremio, and it is because of the uh, native performance acceleration capabilities. And one of the feature called Dremio Reflection, which understand user queries. So when the user requests coming from the BI tools, or maybe data engineers sending queries from the Jupyter notebooks, they head to Dremio views, and then views understand from where the data is coming from, the underlying sources, and it has a capability to rewrite the queries, and whatever internal reflections it has created, it can use them and change the reflection that this query needs that particular reflection. It can use that reflection. The other thing Dremio is intelligently doing is that Dremio is understanding user query pattern, and based upon the pattern, it creates intelligent reflections in the background, and those reflections are not only designed for a particular query, but it can help to multiple queries. And the middle engine which you see, Dremio rewrite SQL, that matches between the SQL queries coming from the users versus what are the reflections available, and this whole process is automatically tuned by Dremio. So no user interaction required. User will just keep on sending queries, and Dremio understanding user queries and automatically using the reflections, and making the life easy for the users. So the end goal is that without doing further manual tuning, the end users see the performance from the Dremio. Uh, one of the thing, like people ask, like how it differentiate from the other platforms. It's a similar platform. So I put into the three categories. One is the autonomous optimization. So uh, you know that Dremio has a engine which is based upon Apache Arrow, which does the columnar data processing, and which is super fast as compared to the traditional engines. We also have inbuilt workload management. We understand what kind of queries are coming, the complex or small. Then we route them into different engines and make the queries faster. Our query tuning and query rewriting capability is fully transparent. You can go into the query profiles and definitely look into that. The other thing which makes Dremio faster is the Iceberg clustering. That is also a native feature in Dremio. And you can, when you define the Dremio Iceberg tables, you can define like on which keys the clustering can happen, and that clustering is helping queries running much, much faster. We also have a capability to do caching. So if your queries are running repeatedly on the same data set, Dremio caching improves the query, and it uses those caches to run the queries in sub-second. So the overall user experience will be great. The other thing Dremio brings is the context and semantic layer. We have a unified semantic layer, which where you can define tags and whatever metadata definition you are writing, that will be visible for all the users, and you can do the semantic search. You can even throw some keywords and it will definitely search based upon the available data sets, the column definition, table definition. You will be able to find all the things in one place. It's also possible because we are also giving Iceberg REST catalog, which is based upon Polaris, and all the metadata is present in one place. So searching those layer is much faster. You can even do searching on the natural language, and it will start doing data exploration on the metadata and give you the relevant results. The third thing is zero ETL federation. So historically, customers have been using long running ETL processes and pipelines to transform data. With the Dremio capability of connecting to any sources and bringing the relevant data into the processing, makes it super easy, and we also avoid creating multiple copies of data. So you can federate different data sets in one place. You don't need to create a full copy of data or do a transformation and bring it to another table or the intermediate table. The SQL-based transformation happening at the runtime will make that thing much more faster, and overall user experience to join the real-time data sets with other data sets in one place is really great in Dremio. So so with this, like one thing I would like to summarize is that some customer who has been using Hadoop as a big data system in the past, they have multiple components in Hadoop, like they have SDFS, Hive, they have Spark, they have Impala, multiple things. But still, there is no self-service layer and there is no acceleration layer. So some customers who have historically big data play system in place, they use Dremio as acceleration layer, and Dremio connects all those systems like Hive, SDFS, and then creates metadata out of that and creates virtual data sets, and the Dremio reflections make the queries faster for the end user. So we have customers who are using Dremio as the acceleration layer on top of the Hadoop system, and their BI tools or data science tools get the sub-second response from Dremio. And Dremio keeps on understanding user requests and keep on creating the autonomous reflections uh, without doing much changes on the source side. So your source system still remain Hive. So this is one of the journey where customer use Dremio as an acceleration on top of Hadoop. There's definitely the second path where customers are simply moving out of Hadoop and going into a newer architecture, and we will definitely explain about that. But at least if you have a Hadoop system which is not performing well, you can put in Dremio as acceleration layer on top of Hadoop and make your business users' life much faster. So with this, I would like to hand over to Ahmed, who is from MinIO, and he will explain more about the MinIO capabilities.
Yes, thank you so much, Will and Ravi, for the setting the stage and for talking about how our customers can modernize their data lake house. And one of the main essential principles of going to modern data lake house is to decouple the compute from the storage, just to keep the power of dealing with each of those layers in independent way. And this is where MinIO has set the new standards and built an enterprise AI and data storage for that sake. MinIO is a software defined object storage leader. We deliver the world fastest and the most efficient data and AI storage at any scale. We've been dominating, the community for the past more than 10 years now, with around 2 million downloads a day, with 51K plus of GitHub stars, but also as the concept of object storage and the need for having it for AI and data perspective. Also, MinIO and most of our enterprise customers, they considered MinIO and our AI store commercial edition, and they trusted to run it on for their data and AI stack. Most of the 77% of the Fortune 100 companies, they trust and they run MinIO for their data and AI stack. What is the MinIO? MinIO is setting the stage, and setting the data foundation and making the enterprise ready stack. It has all the capabilities that any enterprise need for AI and data perspective. It's considered to be 100% software defined. It can run on any hardware, whether we're talking about x86 or 64 or ARM or commodity hardware. It can run on any place, whether we're talking about edge or on-prem to the cloud. It's a cloud native by nature. It can run on any form factor, and also it can run on permittal. MinIO, it's considered to be the centralized data store to host all kinds of data, whether we're talking about structured, unstructured, semi-structured, or even embeddings and vector data as well. MinIO also, an AI store, is considered to be the drop-in replacement with AWS S3. We're 100% compatible with AWS S3. In MinIO, we're focusing 100% on object storage, and we're delivering it to the best. We are also not like the traditional storage. We are more of an AI and data analytics focus. So we have a lot of ecosystem, and we're having, let's say, tight integrations with the ecosystems from the AI and data. We're having, the most and the rich and the broadest data services that any enterprise might need. Everything from compatibility, integration, automation, administration, security, data protection, monitoring, everything you can find it on a one place and in one solution. And why our customer they choose us, and why the enterprises they choose us is for many reasons. And I'm putting here on the slide like the main reasons why our customers they choose MinIO and AI Store. One of the major reasons is that customers who leverage S3, which is the de facto standards nowadays for the modern applications. And for all the AI and the data ecosystem, they want to go and they want to have an S3 and S3 compatible. And you rest assured with MinIO, you don't worry much about you're having no risk. If your software is running on S3 and they want to S3 compatible, there is no risk with MinIO. You get 100% and fully compatible S3 APIs from MinIO. And whenever we talk about the architecture, because this is very important whenever we're talking about performance, scale, and how easy to run, and how easy and how portable it should be, and how simple to deploy, and how simple to manage as well, then we're talking about what is the architecture. And the MinIO architecture, it's been built from the ground up to be a cloud native and to provide a cloud native object store. We have reduced the legacy architecture where it has multi-layers that is said to be a bottleneck for performance and scalability. It's very neat and very simple with a sort of a flat namespace. You can have everything in there, and with no metadata at all. Metadata in MinIO, it runs alongside with the data itself, so you have a data consistency all the way along. And you can scale to exabyte with no problem at all. And that's why whenever we're talking about performance in MinIO, so in performance, there is no limit on performance whenever we talk about performance in MinIO, like with the legacy approach of, the object stores and how others they're running object store, they have, let's say, a cap when it comes to the performance, like how much they can reach in terms of performance, but with MinIO, we can take advantage of any underlying hardware. In reality, actually, we can reach to the line speed of the underlying hardware, and in our recent tests, we can achieve like around 202 terabytes per second worth of throughput, and that is not the limit, but this is what MinIO can reach based on the underlying hardware that we can run on top. And MinIO is a cloud native architecture, like everything being built as a cloud native architecture. And whenever we talk about also scalability, MinIO also has no scalability. We can scale linearly with the additional nodes that you do add to the cluster, and we have no cap. Actually, we're having multi exabyte of production running nowadays in MinIO. And that again is not the limit of what MinIO can reach, but this is like what the enterprises they manage to run on top of MinIO, and there is no limit when it comes to capacity. Whenever we talk, so you can scale with no limit at all. And also, whenever we talk about the cost, which is very important, like everything is built on MinIO, everything that how we're protecting data and how we manage the data, like leveraging erasure coding and other technologies, we can reduce the overall cost by 40% for any vendors or any enterprises who is like having more than 10 petabyte of scale. That is, in average they can reduce around 40% of their cost. And I don't want to also mention that MinIO is like AI and data focused. We're having an tight integration with the AI and data ecosystem from that space. And last but not least, one of the most important things that our customers, they really treasure and they really like, which is our support. Like, we don't offer the traditional support of what other vendors might offer, like having a sort of tiers or having sort of layers. Like whenever you open a case, you go through layer 1, layer 2, layer 3. MinIO is going to give you the access direct to L4, which is the engineering, the people who help to develop the code. They will come and help you to solve your issues, which is you're going to bring and make your issues resolutions much and way faster. And with this, I would bring it back and leave the floor to Ravi to take us forward. Ravi, over to you.
Okay. Thanks, Ahmad. I would like to mention that how customer have been able to migrate from Hadoop to a newer architecture. And in the newer architecture, they have a decoupled approach where Dremio is acting as a compute layer, and the traditional storage has been migrated to S3 compatible storage. And I would like to bring that story here. So historically, customers have been using Hadoop, and they have a lot of smaller components. And one of the challenges they face is that even if they have all the data ecosystem in place, but they do not have any rich semantic layer in place. So what they have been doing is they have been trying to bring data from Hadoop to a data warehouse and then give access from data warehouse to the consumer applications. In some places, if they try to create data warehouse inside Hadoop, they still do not have a rich semantic layer. And if customers want to join data set or federate data set and play with different data products in one place, definitely that was not possible. The other thing is that being a big ecosystem within Hadoop, there are different smaller components, and for each component you need a different skill set, and all the versions has to be matching with a certain predefined version matching, and then you will have to manage all the components in one place. obviously, with these challenges in place, customer wanted a more decoupled architecture where both the compute layer and storage layer are very well managed and they can scale independently without having so many components. So what the approach has been there for many customers is that they first modernize the query part, I mean the query layer, and retaining the Hadoop data as it is, and giving more capability for the self-service users so that the end user can start playing the data which is available in Hadoop, but from Dremio that is, making visible to them. The second stage is that they migrate off the Hadoop and bring data from SDFS to MinIO. And the third is that they create a data layer which is ready to go into any public cloud as well as giving the same experience on-prem. So the first thing, as I said, in the modernization journey is that changing your query engine. So without disturbing your current SDFS data sets and your storage location, we bring Dremio platform parallel to Hadoop, and then we start just migrating the Hive and other queries which is running on Hive and Impala or Drill to Dremio. So all the queries will be coming to Dremio, and Dremio will connect to the underlying Hadoop systems, and then user will start playing with the data. So there will not be any change upfront in terms of the user experience. The result is that the query performance will increase with Dremio. Now, the second thing is that when they bring Dremio in front of the Hadoop, they will also have the capability to join different data sets. That means they can join data sets from other databases like Oracle or maybe cloud databases as well. And without doing the ETL, they can bring all data in one place and join it and serve to the different users and applications. So first thing was just to bring the SQL query engine. The second part is that giving more self-service capability to the end user by having a capacity of data federation. Then the third thing is the migration of SDFS to MinIO. Ahmad is here; he can explain more about this.
Yes, so absolutely. So once you've taken care of, moving the analytics from, the traditional Hadoop ecosystem into Dremio, and you've taken care of the whole, federation and connected to multiple data sources. Now the question is what you're going to do with the data itself. And here where like the easy migration steps with no disruption to your data would come to the picture. So like moving from HDFS to MinIO, it's like moving, seamlessly the data, leveraging many of the tools. Like you can also use, MC Mirror, or you can also use this copy to copy the data from HDFS to MinIO. And once that has been copied, also you would be able to maintain the whole namespace and the whole prefix of the data itself. So if you're running, the application as maybe, the Spark, and then you have a database name, and then you have a data table name, and then you have a record, you can maintain the same prefix on MinIO, and you don't need to change the structure of your, of your records. And from there, from application perspective, instead of accessing the data using the HDFS URL, they can accessing the S3 using the S3A connector. So you can like moving off from HDFS to MinIO object store with no disruption actually to your data at all. And also when moving to the next slide and talking about the iceberg and the tables. So the thing is, we've taken care of the unstructured data, but what will happen also to the structured data? And also from that perspective, like moving from Hive tables to the iceberg, like why not to also modernize the Hive table and making it more richer and based on a newer platform, like leveraging the open table format from Iceberg. And this, which will give you like a lot of better performance, is going to give you the capabilities where you can do schema evolution, as well as would help you to travel back in time, as well as you can have, a complete data warehouse capabilities with the, the openness to connect to any engine like a Dremio in this case, where you would be able to have get the best of a breed from analytics perspective, as well as from the performance, and leveraging an open standard tables like an Iceberg. So you don't left behind all the data from unstructured and structured perspective can be moved to more open standards, like leveraging S3 from MinIO and Iceberg as an OTF capabilities. Ravi?
Thanks, Ahmed. So obviously, with the decoupled architecture, we also have a capability to now run the ACID-based transactional table with Iceberg, and all the data is stored in S3, even including Iceberg metadata. Everything is in MinIO S3. So what, as I show you in the earlier slide, customer has been using Hadoop, and then Dremio comes as acceleration. Now, if you move from SDFS to MinIO, and if you still position Dremio as acceleration layer, that is all there. So Dremio has the capability to connect MinIO. All the Iceberg tables, data, and metadata is all stored in MinIO. Dremio can query that. If you want to bring other Hadoop ecosystems, apps like Kafka or Spark, which would like to bring data into Iceberg table, definitely they would be able to write directly into Iceberg. Dremio provides native connection capabilities and Spark libraries, so that Spark or Kafka or Flink can connect to Dremio and write data into the Iceberg table. So if you see in the right hand side, we are not doing any disturbance for the consumer or the consumer applications like Jupyter notebooks or BI dashboards. Their experience is not changing. They are still looking the same semantic layer which they have designed in the Dremio. In the back end, we have migrated the SDFS to MinIO. Now, if you see from an overall architecture where we are giving value to the end user, is that we have first of all decoupled. Now they are getting MinIO as a new data lake. Obviously, with MinIO as a new data lake, they still have the capability to connect to different databases, and they can federate everything in one place in Dremio. Apart from the federation, they get a intelligent catalog which is powered with Polaris. So Dremio Enterprise Catalog is there. They can definitely do a lot of table optimization works, which is inbuilt into Dremio. So Dremio, along with the Polaris catalog, has inbuilt capabilities of table compaction and cleaning the orphan files, all these services. On the top, in terms of query processing, you will get a rich semantic layer. You get a open search capabilities, which makes data engineers' life very easy when they come to Dremio interface. They seamlessly see all the data products in one place. They can drag and drop, play, creating data products, and ultimately the reflections, which is helping BI tools to run the queries faster. So this is the overall stack where we fit into the overall customer journey in terms of data. And with the new architecture, after replacing your Hadoop with MinIO, your end user experience is now enriched. It is much faster, and they can see everything in one place. So I would also like to bring one customer success story here. Nomura is one of the financial sector company, and they have been using Dremio on cloud as well as on-prem. And in the on-prem, they have been using Hadoop as a platform. They have been struggling in terms of managing two infrastructure because the architecture was a little different in on-prem, and also in Hadoop the data is stored in data nodes, so they will have to pay a lot of hefty amount to the Hadoop support guys, and still they have to manage the fat clusters where data is distributed but is still stored in the physical data sets like in the data nodes, and the expansion was not that easy. So they wanted a flexibility like whatever they're getting in cloud. So they wanted a S3 compatible storage on-prem. and they wanted an engine like Dremio, which can be decoupled, and they do not have any dependency on each other. So as of now, they have S3 running on cloud, and they have on-prem MinIO, and all the data lakes on-prem in MinIO and S3 both is consumed by Dremio. And in Dremio, they have one cluster running on EKS, they have another cluster running on Kubernetes on-prem, and they are still able to leverage all the Spark pipelines which are writing into MinIO, and they still use the traditional Jupyter notebooks and other application tools as it is without doing any differences in terms of the data consumption side. So their overall cost has been optimized, their architecture has been more simple, and the performance of the queries and the federation of two different data sets in one place has overall given more than 50% performance improvement from the traditional data set. So with this customer journey, I would like to now pass into Will to explain you more how Apache Iceberg and open architecture is helping customers here.
Great, thank you, Ravi. So as Ahmad and Ravi touched upon there, we talked about open architectures, and Iceberg came up a few times. So I'm going to close out the webinar with a few thoughts on both of those topics and how they lead to vendor independence. Next slide, please, Ravi. So why does open source matter? So open source software drives innovation in your data architecture, and it also fosters community-driven innovation, progress, and flexibility. And this leads to a few things. So you avoid data silos and vendor lock-in, because closed architectures tend and encourage data silos. But if you embrace an open format and standard, you have the ability to pick whatever tool, framework, and most importantly, vendor you want to use. You also accelerate innovation through ecosystem integration. So you're not just dependent on one vendor's roadmap. You have multiple vendors, that's multiple roadmaps, but you also have the community-driven software's roadmap, which is great for really innovating and bringing your stack forward and giving you powerful, useful features. Talking of features, community-driven software also develops features that are needed in real-world scenarios. The people that contribute to open source projects work in the industries and are companies that use this software. So they tend to prioritize and focus on the features that they need rather than things that a company or vendor may think is useful. And this really helps drive useful applications. And finally, you enable true data democratization. So by having this freedom to pick the tools you want to use and the ways you want to access your data, it really just opens up, and you can really open your data up to everybody who wants to use it. So you're not locked to a vendor's features. You have whatever tools on a company level or even within a team level to access the data you want to do, and it's made easy because you have these standardized protocols and interfaces. Next slide, please, Ravi. So open source is very useful, and we believe that here at Dremio, where we spearhead open source software standards. So here are 3 Apache Software Foundation projects that we have either co-created or contribute to. So back in 2015, we have Apache Arrow, which is an in-memory transport format, which we co-created. We also are a key contributor and educator around Apache Iceberg, so much so that we wrote the book on it, literally, for O'Reilly. And then again, Apache Polaris last year, which is an open data catalog that we launched with Snowflake. And again, we wrote the book on it. Next slide, please, Ravi. And you can see that in our stack. It's not just education and lip service. Apache software is throughout our stack. So we write our data in the Apache Parquet. That's our file format. For metadata, we use the Apache Iceberg table format. Our own enterprise data catalog is powered by Apache Polaris under the hood, and our query engine utilizes Apache Arrow. Next slide, please. So a little bit about Iceberg. I'll start off with explaining what it is. So I mentioned it's a table format. So this is metadata that defines your data table or your data set. It contains things such as the schema, So what your attributes are, what data types they are. It discusses your files, lists your files. So which files make up your data set, and where they are physically located in your storage. And it also tracks the history of your data set. So what changes were made, when, and by who. So it's not a storage engine, it's not an execution engine, and it's not a separate service that needs to be running. It's just a format for writing metadata into. And there are three leading standards, three leading formats. You have Apache Iceberg, you have Delta Lake, and you have Apache Hadoop. And these all give you powerful features like Ahmed mentioned earlier. So you have schema evolution, the freedom to change your schema and your attributes without rewriting your data. You have time travel, which makes it really easy to do analytics. But also you have rollback because of this history. So if you make mistakes and mess things up, you can recover very easily from that. You have ACID compliance on your transactions, which you didn't have with Hadoop. And you just have faster querying due to features that make up the standards. Next slide, please. But those are the general table format features for those big three. But we've been talking about Iceberg. So Iceberg and Delta Lake were sort of neck and neck for quite a while, sort of 2021 to 2022, sort of a two-horse race for the formats. And you could see a lot of people starting to adopt Iceberg. So Dremio was down there at the beginning. We got on board early, along with a few of the hyperscalers. But then last year, things started to shift. No, maybe last year, 2 years back, 2023. And lots of providers and vendors in the space started to back Iceberg. So you had hyperscalers, you had large companies like Confluent, you had smaller projects like DuckDB and organizations like that. And then as of last year, and that's sort of officially the start of this year, even Databricks is on board with Iceberg. And some of the big announcements that kind of signified this shift last year were Databricks acquiring Tabular, who created Iceberg, and also the launch of the Apache Polaris data catalog, which we launched with Snowflake last year. Next slide, please, Ravi. So here are the key benefits around Iceberg. So these standards, Delta Lake and Iceberg, have common features, but some are unique to Apache Iceberg. So with Iceberg, you get a better experience with managing your data because you abstract the physical data. So whatever your data lake is, wherever you're physically storing your data, looks like any other database. You get concurrent read and writes, which is typically a database or data warehouse functionality, but your data is stored in a lake. So that's very useful. You have partitioning features such as hidden partitioning, which means your users don't actually have to care about how your data is physically located and how it's physically stored. You have your schema evolution, which I've mentioned already, and lots of optimization features, which are automatic. So your users can be opened up to less technical people because technical tasks such as data engineering and optimization can get handled for you. And on the other hand, you also have higher performance. So the metadata stored in Iceberg contains everything needed to accelerate your query planning and execution of your queries. So you have efficient updates, whether you're rewriting a data file or writing a delete file, making deletes to your data. And you have enhanced cost-based optimization via file statistics, which in Iceberg are stored in what are called puffin files. You also have less data to read. Your query planning is very efficient because it intelligently knows which partitions to open to look for the data you want to query, and also which files within that partition to open. And this all compounds to make querying very quickly. On the other side, this also reduces latency because you're not listing everything in your bucket like you would do typically with other software. Next slide, please. And really the key feature, the real selling point of Apache Iceberg is its REST catalog specification. And this really opens you up and gives you freedom. So the REST catalog specification is a spec for how query engines or your compute talks to your data catalogs, which handles your data. What this means is you can come to the table with any engine that adheres to this spec, can talk to any catalog that adheres to the spec. So you can pick and choose whatever you want. Next slide, please, Ravi. And that is it on open architecture. But if you want to actually try out a lakehouse and see this in action, see this REST spec hands-on for yourself, we're running a range of webinars here at Dremio. So if you scan this QR code, you can go and spin up an Iceberg Lakehouse and try querying it using Dremio and PySpark and various query engines, and just play around with making a data lakehouse. Next slide, please, Ravi. And that is it. Thank you for listening, everyone, joining us here today. I'll get the rest of the speakers on stage, and I'll just see if we have any questions from the chat. Okay, I don't think we have any. I can't see any here. Maybe it's an issue with the platform, but let me, again, thank everyone for attending and listening, and thank you, Ahmed and Ravi, for joining me here today to discuss Hadoop, MinIO, and Dremio. I've had fun. I hope you two have as well. Any closing comments? No? Okay, great. Well, thanks again, everybody. See you on the next webinar.
Okay.
Thank
Thanks
you.
everyone for joining. Thank you.